Do you know about quantum computing? We are talking about a technology that takes advantage of the laws of quantum mechanics to solve problems that are too complex for traditional computers. In this video, we'll tell you everything you need to know about quantum computing. But first, please like, subscribe to TechStar, and then sit back and relax. What is quantum computing? When mathematician Alan Turing laid the foundations for algorithms and modern computing in 1936, he never believed that machines would evolve to solve some of the most complex problems in science. The machine that he created at that time could recognize formal languages autonomously, and at the time, this advance changed the way of analyzing reality. Almost 100 years later, computers advanced to the point of solving mathematical problems in moments that would take a human hours or days. However, that does not mean that its analytical capacity is infinite. Even today's most advanced and powerful machines can take decades to solve the most complex challenges related to physics, chemistry, or biology. For this reason, IT experts have been looking for solutions to these limitations for several years now, and as they explain, quantum computing is the answer. This is a technology that takes advantage of the laws of quantum mechanics to solve problems that are too complex for traditional computers. What is the origin of quantum computing? Before moving on to how quantum computing works, it is worth taking a brief look at its recent history. The international consensus of computer science experts recognizes Paul Benioff as the ideologue of quantum computing. In 1981, this American physicist unveiled his most extensive and complex theory. It proposes to take the quantum laws and apply them to computing. Quantum mechanics was carried out between 1900 and 1925 and remains the cornerstone on which chemistry, condensed matter physics, and technologies ranging from computer chips to LED lighting are based. Today's computers, which for quantum professionals are already traditional, read bits, which can take the value of 0 or 1 and are considered their minimum units of information. From this system, the machines work at the level of electrical voltages. Benioff's proposal is to modify this behavior so that computers use quanta, which can take the value of 0 or 1, but also 1 and 0 at the same time. Theoretically, this is possible thanks to the laws of quantum mechanics, and the benefit is that more operations can be carried out at the same time. Therefore, the resolution of a problem is significantly shortened. How does this technology work? As stated above, quantum computers do not work with bits. The smallest unit of language that a machine of these characteristics can interpret is called qubits. These indicate the number of bits that can be in overlap and thus condense more information. A simple example to understand this model is the following. In a traditional system, a combination of 3 bits can generate 8 values that are different from each other, but the record that the machine makes can only take one of those 8 values. The big difference that quantum computing establishes is that thanks to the superposition of bits, 8 different values can be taken at the same time. Therefore, the time it would take to perform an operation with a quantum model is exponentially less than what exists today with traditional computers. A quantum computer with 30 qubits could process 10 billion operations per second. Supercomputers versus quantum computers. Today, the most powerful computers in the world are known as supercomputers. They are made up of thousands of classic CPU and GPU cores and can take up entire rooms. When scientists need to solve a mathematical problem or equation, they often turn to these machines. However, even the most powerful supercomputers struggle to solve certain types of problems. If a supercomputer freezes, it's probably because the traditional big machine was asked to solve a problem with a high degree of complexity. When traditional computers fail, it is often due to complexity. When talking about complex problems, reference is made to modeling the behavior of atoms in a molecule, or the process of examining a large database of protein information to identify patterns of function or reaction to environmental change. A supercomputer would use all its power to determine these solutions by force. Through its operations system, it would verify all the possible options one by one until reaching the indicated conclusion. This could take years and would therefore be inefficient, since by then the response would be useless. In addition, a large storage capacity would be required to save the information that is generated in the process. Meanwhile, quantum algorithms work from a different paradigm. What they do is create multidimensional spaces in which the patterns that link particular data points emerge. The time required for this is much less, since a procedure called quantum parallelism is used that analyzes all the possibilities at once. This happens because a qubit by itself does not have a specific purpose. What is important is its ability to put the quantum data that these tiny units of information contain into a superposition state. So this represents a combination of all possible configurations of the qubit the machine is working with. Along these lines, another crucial characteristic of qubits is their entanglement capacity. This is a quantum mechanical effect that manages to correlate the behavior of two separate things. By achieving the entanglement of two qubits, any change that takes place in one of them will directly impact the other. From this, quantum algorithms find solutions to complex systems thanks to their ability to take advantage of these relationships. What are the components of a quantum computer? Despite being complex machines, quantum computers are not very large. Those developed to date are no larger than a wafer, so they do not require much physical space, as is the case with a supercomputer. However, that does not mean that the components that surround it have the same dimensions. Cooling equipment. The hardware system that accompanies the quantum processor can reach the size of a car. This is because the system requires much more sophisticated cooling equipment than a traditional computer. The latter usually use small fans that are enough for the equipment to operate correctly. But for a quantum computer, this is not enough. In this type of machines, a superfluid equipment is necessary that allows the processor to reach ultra-cold operating temperatures. Early prototypes, like Google's Sycamore quantum processor, are encased in vacuum chambers and immersed in huge cryostats that keep the chip at -273.05 degrees. They work, then, at 0.1 degrees above absolute zero. Recently, a note published in the journal Nature, specialized in science, revealed that 2 teams of researchers have managed to make quantum qubits perform their function at a temperature between 10 and 15 times higher. They still need extremely low temperatures, however, between 271 and 272 degrees below zero. Superconductors. By operating at such low temperatures, the rest of the materials that a quantum computer requires also have special characteristics. For example, some processor components must allow electrons to move between them without resistance. For this reason, superconductors are used, which allow electrons to pair up and carry charges through insulators. This process is called tunnel effect. Control. Another important aspect of operating a quantum computer is the control of the qubits. To achieve this, those who operate these machines shoot microwave photons at the minimum information units to determine their actions. In this way, they can be made to hold data, change data, or even read individual units of quantum information. How much does a quantum computer cost, and which companies have it? Many years ago, NASA purchased a quantum computer that cost approximately $15 million. The same, called D-Wave 2, is not only used by that organization, but is also shared with companies such as Google and private scientists in the United States. On the other hand, IBM's quantum computer is the first installed outside the United States. It is located in Stuttgart, Germany, and is called Q System 1. Although there are no exact references to its value, it is estimated that it is similar to that of the NASA machine. In addition, IBM has the support of countries such as France and Germany that have set themselves the goal at the state level of being pioneers in this domain. Such is the commitment that France allocated a total investment of $2,180 million over 5 years, and Germany one of $2,000 million to develop a quantum computer in 2025. What can a quantum computer be used for? As mentioned above, there are different industrial fields in which the full operational potential of a quantum computer can be used. One of them is the development of electric cars, and currently companies like Mercedes-Benz are already making progress in this regard. The goal of the automotive company is that by 2039 all the cars they produce will be powered by renewable energy sources. For that, the manufacture of electric batteries is necessary. But as Mercedes-Benz experts mention, Nobody knows exactly what happens inside these devices at a molecular level. What's the future of quantum computing? Currently, few companies have the possibility of having quantum computers. It is expected that by the end of the decade, this context will change and more companies will be able to count on these machines. Thus, the amount of information available to make decisions in the different social and academic fields will increase, and solutions to problems that are impossible to solve today will be achieved. In the short term, the challenge facing quantum computing is to increase its processing power. As mentioned, IBM wants its next model to exceed 1,000 qubits per second, which represents one of the most important milestones in the history of this discipline. If you enjoyed this video, don't forget to hit like, the subscription button, and the notification bell to get notified when new videos are uploaded from this channel. Please share your thoughts about how the 10 mind-boggling fact about quantum computing that everyone should know in the comment section below. Thank you.